going to work on graphing rational functions. And a rational function is also called an inverse function. So we're going to start with a very, very basic rational or inverse function, which is f of x equals 1 over x. So if we were to go through and draw our xy coordinate plane, it would look something like this. It would start over here in quadrant 1. It would be close to your y-axis but not actually touch. And then it would also be here in quadrant 3, kind of doing the same kind of idea. Okay. So in the very basic function, it keeps getting closer and closer to the x and y axis forever, basically, but it will never touch. So this one has two asymptotes, a vertical asymptote and a horizontal asymptote. So a vertical asymptote is x equals, and your horizontal asymptote is a y equals. So in my first function, this one right here, basically this right here is my vertical asymptote. It's a vertical line that the function gets closer and closer to whatever actually touches. And an asymptote is a line that it gets closer and closer to whatever actually touches. So this red line right here is my vertical asymptote, and that is going straight through my x-axis at 0. So x equals 0 is a function of my line that is never actually going to touch. Now my horizontal asymptote is a straight line that goes straight through my y-axis at a certain point. So in this one, my horizontal asymptote goes straight through my y-axis at also 0. So your very basic vertical or rational function is going to have a vertical asymptote of 0, x equals 0, and a horizontal asymptote of y equals 0. So we're going to start having these ones in Math 2 that start shifting around a little bit. Let's say x minus 1. So very similar to all the other functions that we've seen, something that's with your x value is what's going to move you to the left or the right, and it's actually opposite of what you would think. So this one is actually going to go to the right one space when I go through and graph this. So let's take a look at what this graph would look like. Okay, there's my normal graph, my xy coordinate plane, and instead of my vertical asymptote, this, let me circle it real quick. This right here is kind of going to tell you what your vertical asymptote is going to do with your function. So when I look at this xy coordinate plane again, instead of going through the origin, it's actually going to have to go to the right one. So there's 1 on my x-axis. Now usually when we draw these, we try to put a dashed line, best that I can with this marker. Alright, so when I go through and look at this graph, that dashed line, that dashed red line, is my vertical asymptote. So I can go ahead and list that. That's my vertical asymptote. And that one's at x equals 1. And instead of my function kind of butting up next to that y-axis, it's actually going to butt up next to this asymptote. So my function is going to look like that. And same thing on this other side. Instead of getting closer and closer to that y-axis, it's actually going to cross the y-axis and get closer and closer to that asymptote line. So there's a graph of my function. This one, my horizontal asymptote, is also y equals 0. Okay, because it's getting closer and closer to my x-axis, which is y equals 0, but never actually cross. So if you need anything from the screen, go ahead and get it. Alright, so we're going to try another one. Let's try 1 over x, let's say plus 3. Well, again, that number underneath there with our x value is basically what's going to tell us to go to the left or the right. This one actually wants to go to the left 3 spaces. So when I go through and draw this, and there's my xy coordinate plane, and my vertical asymptote, instead of being the y-axis, is going to have to go to the left 3. And again, we're going to try to draw on a dashed line the best that we can. And there's my asymptote. So in this one, my vertical asymptote is at x equals negative 3. And I want to go through and now draw this. You can hear my kids in the background playing. But kind of start up here next to the asymptote line, and it's going to get closer and closer to that one, but never actually touch. And same thing down here. Okay. This one again is going to have a horizontal asymptote of y equals 0, which you're going to see is pretty much common with a lot of these. Alright, so let's look at one that has something other than 0 for my horizontal asymptote. That might be something like x plus 2 minus 1. Okay. This right here, just like it has before, this really just tells us what our vertical asymptote is. So my vertical asymptote is going to be x equals, and again it's always opposite sign of what you would think, so it's going to be negative 2, because this thing went to the left 2. Now the new one is this minus 1 behind it. This right here is actually going to tell you your horizontal asymptote. My horizontal asymptote, instead of being 0, it's going to be negative 1. It's going to be the same side as it was before. So with this one, I'm going to go through and draw on my vertical asymptote. I have to go to the left 2, so that means it's going to be over here somewhere. Kind of missed my line a little bit, but and then minus 1, so it's going to be down here. Sorry, I'm trying to draw a dashed line the best that I can. There we go. Alright, so this function, again, it's going to start right up next to this asymptote. Instead of the x-axis being the line it gets closer to, it's going to get closer and closer to that asymptote. So it's going to look something like that. Alright, so let's look at some that have a number other than 1 at the top, possibly even a negative. So we'll check that out first. So if you need anything from the screen, go ahead and get it. Alright, so let's try f of x equals negative 1 over x. We'll just do the very, very basic one. So this one's going to have a vertical asymptote at x equals 0, because I'm not going to the left or right, and a horizontal asymptote of 0 as well, because it's not going up or down. Now, our previous very basic one was in quadrant 1 and quadrant 3. All this negative does, really, is this just moves, instead of being in this quadrant, I'm actually going to be in quadrant 2 and quadrant 4. So this one's actually going to be starting out here and here. All it does is just flip it over. So just like if I had f of x equals negative 1 over, I don't know, x plus 3, for example. Well, I can see my vertical asymptote is going to be at x equals negative 3. My horizontal asymptote is going to be at y equals 0, because I don't have anything added or subtracted behind it. Remember, the vertical asymptote is opposite sign of what you had under there with the x. So this plus 3, and this one means that I'm going to go to the left 3. 1, 2, 3. So again, I'm going to try. That worked out a little bit better. So now, instead of being in quadrant 1 and quadrant 4, I'm going to be up here. So I'm tucked up on this side of it. And same thing on this side. Sorry, my child's playing in the background. Sorry, I had to move rooms. Okay, so now let's look at some that have a number other than 1 or negative 1 in the corner. So let's say if I had something like y equals, I don't know, 3x minus 2. Okay. Well, in this one, I can tell my vertical asymptote is going to be at x equals 2. I'll need this equals right here. And my horizontal asymptote, I'm not going up or down at all, so this is going to be at y equals 0. So, we know that I'm going to have to go to the right 2. No, not the greatest drawing in the world. Okay, so what we had before is if this had 1 at the top, let's say, we would have been in quadrant 1 right here, and quadrant 3, which would have been right here. Okay. So now in red, I'm going to do, let's say the top number was a 1. If the top number had been a 1, it would have just gotten a little bit closer to the origin in that curve. So it looks something like that. So in all honesty, whether the top number is a 1, a 2, a 3, a negative 1, a negative 2, a negative 3, it's really not going to matter. When you guys are sketching a graph, really all you're looking for is the asymptotes to it.